Welcome to our deep dive into the exciting world of fusion energy. In this video titled, Fusion Energy Breakthrough, Are We Closer to Unlimited Clean Power? We'll explore how fusion mimics the processes that power the sun and discover its potential to produce abundant, carbon-free energy. With recent breakthroughs paving the way for a cleaner future, we will examine the promise and challenges of harnessing this powerful energy source. Join us as we uncover the collaborative global efforts behind ITER and what the future might hold for fusion energy. 1. Fusion mimics the sun. Fusion energy is nothing short of a marvel, as it seeks to replicate the very process that fuels the sun. At its core, fusion involves the merging of hydrogen nuclei to form helium, a reaction that releases an astonishing amount of energy. Imagine the sun's blazing power harnessed right here on Earth. This process, unlike traditional energy sources, is not merely a chemical reaction but a nuclear one, promising a vast potential for energy generation. The sun's energy has sustained life on our planet for billions of years, and scientists believe that by mimicking this natural phenomenon, humanity could unlock a nearly limitless energy source. However, achieving this on Earth requires recreating the extreme temperatures and pressures found in the sun's core, which is no small feat. 2. It produces virtually no carbon emissions. One of the most appealing aspects of fusion energy is its promise of a clean and sustainable future. Unlike the burning of fossil fuels, which releases harmful greenhouse gases into our atmosphere, fusion energy produces no carbon emissions. This means that it could be a game changer in the fight against climate change, offering a way to generate electricity without adding to the planet's carbon burden. The lack of emissions from fusion is not just a theoretical benefit but a real-world solution to the pollution problems plaguing our planet. Clean air and a healthier environment could be within reach if fusion energy becomes a reality. The prospect of a pollution-free energy source is tantalizing, especially as the world grapples with the urgent need to reduce carbon footprints. 3. Recent breakthroughs show promise. In recent years, there have been significant breakthroughs in the pursuit of fusion energy, bringing hope to scientists and environmentalists alike. Notably, experiments at facilities like the National Ignition Facility, NIF, have achieved a net energy gain, where more energy was produced than consumed during the fusion process. This milestone is akin to finding the key to a long-locked door, suggesting that practical fusion energy is within our grasp. Such achievements have been years, if not decades, in the making, reflecting the dedication and perseverance of researchers in the field. While challenges remain, these breakthroughs demonstrate that the dream of harnessing fusion energy is becoming increasingly tangible. Each success inches us closer to a future where our energy needs are met cleanly and efficiently. 4. Abundant fuel supply. Fusion energy's potential is further bolstered by its virtually limitless fuel supply. The process relies on isotopes such as deuterium, which is abundantly found in seawater, and tritium. This stands in stark contrast to the finite nature of fossil fuel reserves, which are rapidly depleting. The sheer abundance of these isotopes means that, unlike coal or oil, fusion energy could provide a stable energy source for centuries to come. Imagine tapping into the vast oceans for energy. The potential is as vast as the sea itself. This abundance not only promises energy security but also reduces the geopolitical tensions often associated with fossil fuel reserves. With fusion, the worry of running out of fuel becomes a thing of the past, offering stability in an uncertain world. 5. Fusion is inherently safe. Safety is a paramount concern when it comes to energy production, and fusion energy stands out in this regard. Unlike nuclear fission, which carries the risk of catastrophic meltdowns, fusion reactions are inherently safe. The process requires extremely precise conditions to sustain itself, meaning that if anything goes wrong, the reaction simply stops. This self-limiting nature of fusion makes it a much safer alternative to traditional nuclear power. There's no fear of a runaway reaction, and the absence of long-lived radioactive waste further enhances its safety profile. For communities wary of nuclear power's dangers, fusion offers a reassuring alternative, promising energy without the associated risks. The peace of mind that comes with fusion's safety could play a crucial role in its acceptance and adoption. 6. Cost and scale are major challenges. Despite its many advantages, fusion energy is not without its challenges, particularly when it comes to cost and scale. Building and maintaining fusion reactors require advanced materials and cutting-edge technology, which come with a hefty price tag. The financial investment needed is immense, and this poses a significant barrier to widespread adoption. Furthermore, scaling up these technologies to meet global energy demands is no small task. The economic challenges are as daunting as they are essential to overcome. As promising as fusion is, the path to making it a viable commercial energy source is fraught with financial and technical hurdles. Overcoming these challenges will require collaboration, innovation, and substantial investment from both the public and private sectors. 7. ITER is a global collaborative effort. At the forefront of the fusion energy quest is the International Thermonuclear Experimental Reactor, ITER, a monumental $22 billion project involving 35 countries. This global collaboration aims to demonstrate the feasibility of large-scale fusion energy, uniting nations in pursuit of a common goal. ITER represents a beacon of hope, showcasing what can be achieved when the world comes together. The project's scale and ambition are unprecedented, reflecting the international community's commitment to finding a sustainable energy solution. By pooling resources and expertise, ITER seeks to pave the way for the future of energy. It is a testament to the power of collaboration and the shared desire to create a cleaner, more sustainable world. 8. Widespread use is still decades away. While the progress in fusion energy is undeniable, widespread commercial use remains a distant dream. Experts estimate that it may not become a reality until the 2040s or later, as significant hurdles in scalability and efficiency still need to be addressed. The road ahead is long and filled with challenges, requiring continued research, development, and innovation. The timeline reflects the complexity and ambition of the endeavor, reminding us that patience and persistence are key. The dream of fusion energy is not an immediate fix but a long-term solution that holds the promise of transforming our energy landscape. As scientists and engineers work tirelessly to realize this vision, the world watches with anticipation, hopeful for a future where clean, unlimited power is within reach.